Dave again with another question in topic 1.1. We're looking at propagation of uncertainty. The length of each side of a cube is measured as 10 millimeters with an uncertainty of plus or minus 2 millimeters. That means that we think that the side of the cube is 10 millimeters, but because of the limit of precision of our tool or some other reason, strange bumps on the side of the cube causing us to get different measurements every time we take a measurement, who knows? For some reason, we think that the side of the cube could be as high as 12 millimeters, or as low as 8 millimeters. So 10 plus or minus 2 millimeters. We're asked, which one of the following is the absolute uncertainty of the volume of the sugar cube? So we need to think about the volume of the sugar cube. The volume is just going to be the length of the side cubed. But we're uncertain about the length of the side. So that uncertainty is going to be propagated through to the calculated volume of the calculated value of volume. So there's going to be some sort of uncertainty in V. That's what we want to know. What we have here is a multiplication. D times D times D. And whenever you have a multiplication, the way that you propagate uncertainty through is to add the percent uncertainties or add the fractional uncertainties of the quantities that go into the multiplication or division. It's the same rule for division. So if I want the uncertainty in V, what I can say is that the fractional uncertainty in V, that's the uncertainty in V divided by the value of V, is equal to the fractional uncertainty in the length plus the fractional uncertainty in the length plus the fractional uncertainty in the length, or 3 times the fractional uncertainty in the length. Now, what I want from this equation is this value. That's the absolute uncertainty in the volume. So I'm going to rearrange to solve for delta V. Delta V is then 3 delta D on D times V. We could solve from here, but it does simplify a little bit more because we know that the volume is really the side cubed. So we can turn this into 3 delta D on D times D cubed, which allows us to simplify by canceling D on the bottom with one of the D's on the top, and we get 3 delta D times D squared. We know the value of all of these things. Delta D is the uncertainty in D, that's 2 millimeters. And D is the length of the cube, 10 millimeters. It's squared though. So punch that into your calculator. 10 squared is 100, times 2 is 200, times 3 is 600. Millimeters, 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 so that's cubic millimeters.